All right, so systems of inequalities. Let's bring this up. Today is going to be a good review, as well as kind of a little bit of new stuff, but not a lot. We are going to come back to the first part later to talk specifically what a solution means. So we're going to start actually down here in part 2. So if you kind of scroll down to there, this is a great chance to review graphing lines in preparation for our quiz tomorrow. So let's look at this first one. Y is less than x. What's the slope here? 1. What's the y-intercept here? 0. So let's go to our graph, and let's put a dot at 0, and let's go up with a slope of 1. And I'm going to do this in one color, and I'm going to do the other graph in another color. Now, do you remember solid and dotted lines?
Yeah.
Which one is this going to be, solid or dotted?
Solid.
Solid. So let's put a solid line in. Okay. Now do you remember the idea of above or below? Okay. Y is, Y is less than x will be below in terms of shading. So just shade this below. So far we have half of the graph is shaded. But what's different today is we're going to add in a second equation. So I want you to change colors. Good morning.
Good morning.
I'm going to change colors to red. What's my slope of this one? 3. My y-intercept? -1. So go to -1 and go up 3 over 1 and down 3 and back 1. And now we have a second line. Is this line solid or dotted? Also solid. And this line says, this line says it's greater than or equal to, so that's shaded above. Now, above the red line, that's going to be this section here. True? All right, so here's the crux of the conversation. It's going to be important that you shade these with 2 different colors so you can visually see. I want you to tell me where it is shaded both red and blue. Paul? Let me make it a little easier for you to identify. We're going to call this section 1, this section 2, this section 3, and this section 4.
Section 4.
Do we all agree section 4 is where they're both shaded? Yes. Okay, so section 4, I'm going to shade that in green. And section 4 is our answer. Nothing else is our answer. Just section 4. Everything else that is now just shaded with one color is not our answer. So the answer is just section 4. Does that make sense?
Yes.
Because how many things need to be true to be a solution? You need to be both above the one line and also below the other line. So our answer is really not section 1, 2, or 3, but really just the line going up, the line going down, but not these top lines. So just this green section here. As in the number 4, that was just an arbitrary number. We were just trying to label it so Paul could clearly say something to me in response. All right, let's go down to example 3. I'm waiting. Go ahead.
Sorry.
That's okay. Do you see why colors are really going to be helpful here?
Mm-hmm.
So you want to probably go off, and if you happen to be on paper for some reason, you want to be using a pen and a pencil or something like that. All right, let's move down.
We need to make it.
We're going to have to do the same thing here, but first I must do what first?
Make it y.
Okay, so who can solve the first equation? Go ahead, Lydia.
So write it. Well, you don't have to. But
Y is?
Greater than x minus 1.
Okay, so let's graph that. So minus 1. So my slope is 1. My y-intercept is negative 1. Catherine, what do you think? Solid or dotted?
Dotted.
Dotted. Does everyone agree with her?
Mm-hmm.
Do we know why?
It's not equal to.
Good, it's not equal to. Okay.
Quick question.
Yes, sir.
This key that I got from your office, the work study key, will that get me upstairs to grab some desks? Perfect.
Yep.
And these 2 desks sitting out here, are you guys use those?
Yeah, we use those. But if you need those, you could have those and I could replace those.
That's okay. I'll go get them.
All right, greater than. Where are we shading? Above or below?
Above.
Above. So shade above. Don't shade too much above because we're looking for where two things are going to do what? Intersect. So if you shade too much above right now, it's going to get confusing. All right, change colors. Catherine, if you could close that door, that would be great. Who can solve the second equation for me? Go ahead, Paul.
Y is greater than negative x plus 3.
Okay. So my slope is negative 1. My y-intercept is 3. 1, 2, 3. Slope of negative 1. Solid or dotted, Paul?
Dotted.
Dotted. Okay. Once again, a dotted line, guys, if you remember, means your answer goes up to the line, but it doesn't intersect it. It says greater than. Trevor, do you remember if that's above or below?
That's above.
Excellent, that's above. So shade above the blue line. Is it pretty clear as to where they intersect? In the top part of the X? Do we agree? So I'm going to make that my answer. I'm actually dotting with green here. So here is my answer. I dotted with green and I shaded with green. So that's where the two parts are both going to be true.
So do you write anything for that answer, or do you just shade it and leave it?
Well, there's thousands and thousands of answers. Any spot that falls in that green section is an answer. How many points are there? Millions. Okay, so it's not a question of, I can't really say x equals 1 and y equals 7. Well, let's see, the comma point 1, 7 is right here. True? And I'll try to put that in a color we can see. That blue dot up there, is that in the shaded section? Sure. So that's one of the solutions. But how many solutions are there? Millions. Okay? But if I have a point over here, this blue dot, that blue dot is only in one of the answers, and so it's not a solution of the whole problem. And down here, this blue dot, obviously not a solution. And even a blue dot over on this section. Okay? It has to be a solution for both to be an answer to the problem. So the only way we can express this is just that. Okay? If I was trying to realistically show this, I would have to erase everything else on our problem in terms of making sure it was all gone. The only thing left you would see was green. That would be the true answer. All right, let's move down to our last one here. Looks like I have to solve some things first. So, who feels comfortable enough to solve the top one? Go ahead, Paul.
Y is greater than negative 2x plus 2.
Really close. Really close.
Minus y.
Good. Now, Paul did a couple things there. First of all, he divided by -2. Stephen, did you pick up that he switched the inequality?
Yeah.
Okay. And now that we switched the inequality, he then also divided everything by -2. So my slope is -2. My y-intercept is -1. So go ahead and graph that. Solid or dotted, folks? Dotted. Shade above or below?
Below.
Look at the
No, above.
look shading above, okay. All right. Paul did a nice job there. Una or Alexis, do you think you could solve the second one for me? Does that look hard? It looks a little harder. Let me rewrite it down here. I see that -y. What would be the easiest way to make that positive? Yeah, just add it. So we have y minus 2 is greater than x. And then what do we do? Add 2. Okay, so my slope is 1. My y-intercept is 2. So go up to 2 and do a slope of 1. Why did I make it dotted? Yep. Where do I shade? Do I shade above this or below this, Anna? It's greater than, so we shade above. Good call. All right. This looks very similar to the last one. So shade in everything in that top section. And our answer will be a dashed green V. A dashed green V. So what I'm doing here is I'm erasing everything that's not green. So theoretically, that's our answer. A dotted green V and filled it in the middle. Everything else was kind of just the work leading to the answer. Make sense?
Do we do that for all problems or other ones too?
Well, the green V is the answer. So long as we're being very clear. If you left it like on pencil and paper, Lydia, then maybe up here you're going to put something like an arrow and say solution or something like that, where you're going to be like, hey, this section here, that's the solution. Or better yet, Haley, is when you originally do your sketching and shading, do it very lightly. So then when you do your final shading, it's obvious that that's the answer. The same thing with your dotted and solid lines. You know, do stuff very lightly at the beginning and then go back at the end and kind of go from there. Because if I went back to this one, I would have to erase all the red, all the blue, right? To finally get my correct answer of everything that I have. Trying to erase my specific, so that would be your solution there. Don't know if it's possible on this one. Let's see. Erase my red. So my answer is just down there, what's in the green. And theoretically, I should also erase these two lines, but I'm going to rewrite them in green first. Okay, so now I can erase my lines as well.
You have to be on the line to look at this one.
Oh. Thank you. So there we go. So hopefully that's fairly clear in terms of what our real answer is. But if you're doing this on pencil and paper, it's going to have a development of a process. So, Tell me a point in quadrant 2. Somebody. A point in quadrant 2. Krista?
-2, 1.
Would you agree that -2, 1 is in quadrant 2? Is -2, 1 Krista's point in this green section? So is it a solution? Oh, pretty obvious visually, right? Okay. Now let's go back to the very beginning. +4, -2. Is that point a solution to our two equations on the left? This is a little bit more difficult because, Luke, we don't have a graph that we can look at. So what we need to do here is just plug them in and see if we get a true statement. So take your section here and kind of cut it into two parts. And we're going to come down here and we're going to say, hey, -2 greater than 2 times 4 minus 3. Well, -2 greater than 8 minus 3. Is -2 greater than 5? No. Do I even need to check the next problem?
No.
Why not? Because it's not even right for the first one. So, is 4 -2 a solution to this system? No. Conclusion? No. All right, let's try the second system. 4 plus 3 times -2 is greater than 1. 4 plus -6 is greater than 1. -2 is greater than 1. Does that work? No. So, do I even need to go to the second equation? No. Now, what if the first answer was yes? I'd have to go to the second one. And what would the second one have to be a solution? Also yes. So how many yeses do you need to get to be a solution? 2 of them. You need 2 of them. So if we go down to here, it would have to fall down in a spot where both were true. Little review. Joey, when do you shade above?
When it's greater.
Okay. Moss, when do you shade below?
When it's less than.
Okay, when it's less than. And our answer is going to be where the shading combines. All right, where the red shading and the blue shading combine to get that green section. And the green section is all that we have for an answer. Make sense? Hopefully that'll be very straightforward. And then if they ask you if a point is a solution, plug it in. How many does it have to work for? Both. All right. So that is it. Let's flip back down all the way to the bottom here. Straightforward. 8 problems as we're looking at this. So questions?